A very warm welcome from NIT Silchar. For today's talk, session 5, we have renowned Professor G.N. Tiwari, sir. He is a president of BAG Energy Research Society and former BAG Delhi professor. The title for his talk is P Modules and its Applications. A brief bio, Professor G.N. Tiwari. Professor G.N. Tiwari was born on July 1st, 1951 at Adarsh Nagar, Sagarpalli, Balia. Dr. Tiwari has joined IIT Delhi in the year 1977 after completing his PhD from Banaras Hindu University as postdoctoral fellow and became professor in the year 1997. He has worked in the area of solar thermal and solar photovoltaic thermal since then with Professor M.S. Sodata. He has superannuated in June 2016. To his credit, he has published more than 650 research papers with 8 index of 83. He has also supervised more than 100 PhD students. He has published more than 20 books and 15 chapters for various editing books. His work has been recognized by various agencies in terms of Hariom Ashram Prerit, SS Bhatnagar Award, ICMRI Bhavnagar, Vigyan Ratna Award, Government of UP, two-time Life Achievement Award, ISAM USA, European Fellow Faculty Research Award, Career 360, and nominated International Idea Award, etc. Dr. Tiwari is a founder member of Solaris, based in UK and organized 3 international and many national conferences at different venues. He has also successfully completed many research projects by many ministries, government of India. He is the chief editor, editors, and reviewers of many international journals with high impact factor. At present, he is actively looking the ongoing project on GISPVT funded by DST at his hometown Balia, UP, at Margopur, Chelkhar, Balia. An international project University, Saudi Arabia under banner of BAG Energy Research Society, for which he is the founder president. He is also involved in opening a school for financially weak and good students at Margopur, Chilarbali. Recently, Dr. Tiwari has been world ranked at 449 with C-score of 3.76 for Sri Swaroop Memorial University, Dew Road, Lucknow, and at 1603 with C-score of 3.34 for IIT Delhi, among top 2% world scientists from India by Stanford University, UK. The total score, if both added, will be 7.10, which will improve world's ranking significantly. Recently, he has also been appointed as Senior Editor of Electrical Engineering, Electronics and Energy, Elsevier for the period of 3 years. Sir, I welcome you, and I would like to request to kindly follow through the session.
From the beginning. Now this basically all my lecture depends on the photovoltaic module and its applications, right? Before understanding this any solar thermal devices, one must understand about the global greenhouse effect. Because global greenhouse effect is applied everywhere. So now we consider the sun as a source of energy. 90% of the energy generated at the center of the sun at the 7 to the power 7 Kelvin. And sun is considered as a fluid, unlike the earth as a solid. So the heat generated at the core is convected to the outer sphere, where the temperature drops to average temperature is 6000 Kelvin, the black body radiation. And from this temperature, the radiation takes place as a electromagnetic waves from 0 to you can say the infinity wavelength. And then the earth is considered as a solid, and there is a crust, and the crust is divided into different plates, and 3/4 of the Earth is covered by the sea, rest is the flat land. But the fossil fuel which is stored inside the earth, like coal, petroleum, natural gases. So the gases escape through these cracks provided at the crust of the earth in the form of carbon monoxide, NOx, SOx, ozone, and other gases. And since it is a lightweight, so it is suspended between the sun and earth, which we consider as an atmosphere. So generally, there are major three parts of our whole system of solar energy scientists and researchers: sun, atmosphere, and the earth. So what happens when the sun emits the radiation between 0 to infinity wavelength? So what happens? This atmosphere has a very unique property, and the property is that it only allows the radiation between 0.3 to 3 micrometer wavelength from extraterrestrial to terrestrial. Extraterrestrial is the region between the sun and the atmosphere, and the terrestrial region is between the atmosphere and the earth. So another way, atmosphere is also called the filter region, because it only filters the radiation which is required for our living organisms. But in the beginning, there was no living organism on the planet Earth. So what happens? These radiation, when it comes on the Earth, is absorbed by the Earth surface, and the temperature of the Earth surface becomes much lower than the 6,000 Kelvin. And at present, the average Earth surface temperature is about 300 Kelvin. So these two things is very important to understand the audience. First, the sun, whose average temperature is 6,000 Kelvin, which emits the radiation. Unwanted radiation is filtered by the atmosphere and reaches the Earth surface. And after the reflection, Earth absorbs the radiation, and the Earth surface temperature becomes 300 Kelvin. Now, there is a misdisplacement law. I think lambda T is equal to 3000. Lambda is in a micrometer, T is in a Kelvin. So if substitute T as a 6,000 Kelvin from the sun temperature, so lambda will come roughly about 0.5 micrometer. And if you substitute T as a 300 Kelvin, so lambda will come roughly about 10 micrometer. That means the average radiation which is emitted by the sun having a wavelength 0.5 micrometer, and the average radiation which is emitted by the earth is roughly about 10 micrometer. So
sir,
now yes.
Sorry to disturb you, sir. Can you click on the slide? It is not changing, sir, still.
No,
Can you click on that?
Still there is no need of slide.
Okay, fine, sir. Sorry.
There is no need of slide what I am talking, right? So
okay, sir, fine.
I will use the slide later on because it is 2 hours lecture. So
okay, sir, fine, sir.
So in that case, what will happen? So the atmosphere has the two main purpose. First, it allows the short wave radiation. That means all the radiation coming from the sun is allowed by the atmosphere to reach Earth. But at the same time, the atmosphere does not allow the radiation coming from Earth to escape. That means the radiation is kept between the atmosphere and the Earth. And since there is an air between the atmosphere and the Earth, what will happen? Its temperature rises. And once its temperature rises, what happens? When the temperature above the snow rises, snow starts melting and it converted into the water, and water becomes the stagnant. That is the one part of the my lecture. So when the ice is converted into water, what will happen? Again, the radiation coming from the sun is considered in the two ways. One is the electromagnetic waves, one is considered a photon. Photon means the E is equal to h nu. That means every particle has the energy h nu. Nu is the frequency, inverse of the frequency is the wavelength. That means when the wavelength is maximum, the energy content will be maximum. And because of that, it is considered that during the peak sunshine hour, the photon has the maximum energy content. Now just see, if this energy content of the photon falls on the water molecules, H2O. So what happens? This photon breaks the hydrogen and the oxygen because its energy is much more than the binding energy of the hydrogen and oxygen. That means the photon deionized hydrogen and oxygen of a water molecule. So what happens? So oxygen is again escaped to the atmosphere, but the hydrogen combined with the carbon dioxide of the atmosphere form the hydrocarbon, and that is how the algae was first formed on the planet Earth. And this is only, and since the color of the algae is the green, because of all this phenomena which I have said, that the atmosphere transmits short wavelength radiation but does not allow long wavelength escape, only because of that the algae was first formed. And since color of the algae was green, atmosphere act as a roof, earth act as a floor, house. So it is called greenhouse effect. Why I have said this thing? Because this phenomena was never explained earlier. Now, transparent glass was invented 350 and 400 years back. And fortunately, we found the transparent glass also has the same property as the atmosphere. Like glass transmits short wave radiation but does not allow long wave radiation to escape. And the most important example is the car. When the car window is closed, solar radiation is transmitted inside, absorbed by the cover, it emits long wave radiation, doesn't allow to escape that. And because of that, when the car is enclosed, you will feel the warmer temperature. And that is called the micro greenhouse effect. So now, as far as our solar thermal device is concerned, or photovoltaic is concerned, in all cases, this phenomena is very important to explain further. So if audience has understood this phenomena, there is not much problem to understand my, you can say, the rest of the lecture. I will give an example. So now the solar thermal device is always based on the behavior of electromagnetic waves, and the photovoltaic behavior acts on the considering the solar energy as a photon. Like algae formation, the process of the algae formation, biomass creation is also known as photosynthesis phenomena, because all the green plants has a maximum 90 to 95% water content, and in similar way as algae form, the biomass is created and plant grows automatically. Since this lecture is not concerned with the photosynthesis, so I will draw attention on the participants to come on the photovoltaic system. First, I will explain you what is the photovoltaic system. Then I will explain you what are the applications of the photovoltaic system in solar thermal devices to make the system self-sustained. Now just see. Now, everybody might be knowing that the state of the solid, liquid, gas. Solid is further classified as a conductor and insulator, but there is a material that is called the semiconductor. So there are P-type semiconductor, there is N-type semiconductor. It is, I will not go much detail on that, otherwise my topic will be diverted. The P-type material means it has an excess electron. One electron acts as the outermost orbit. And P electron has the excess of the hole. That means P-type material can accept the electron and it can donate the, give the donor as a photon. So now, right hand side is the N-type material, left hand side is the P-type material. Just if it is joined together, then what will happen? The electron moves from N to P-type. And the holes moves from P to N-type. Here you have to make it clear in your mind that motion of the electron is opposite to the motion of the proton, and the current direction is always assumed in direction of the holes. So this thing you have to keep in mind to understand the phenomena of solar cell. So now when these moves opposite to each other, what happens? They combine in a region, it is called the depletion region. Just see there is a plus and minus sign the electrons are towards the P material and pulls out from the N material. This is the depletion region, and this depletion region is very, very important to understand the phenomena of the solar cell. Here again, I want to tell you one thing. Anyone, if they have seen the solar cell, so what they might be getting, the N is on the top, P is on the bottom, and the thickness of the N is in the micrometer and thickness of the P is in millimeter. The N is more conducting than P. All these points you should keep in mind so that I can explain you better way how solar cell is concerned. So first here in these two diagrams, just see N and P type material has been shown on the left hand side. The N, which is the negative terminal, is connected to the positive terminal, then it is called the reverse bias. But when the N is connected to the negative, it is called the forward bias. That means the current, outer current by the battery is in a direction to the current created by movement of the holes from P to N. So it is added, because of that it is called the forward bias, and in the left hand side, since it is opposite, it is called the reverse bias. Just see, now we have the battery on the external circuit, so we have the rheostat. So what we can do, by changing the rheostat, we can change the voltage, and once the voltage changes, current is changing. And for kind information, for different voltage, we will have different current. If you plot, then this curve, IV curve, in the forward region and the reverse bias, you can see very well. This is a very, very well-known formula. Sometimes the students refer to the VI curve, but never, it is not a VI curve, it is an IV curve, because variable is on the x-axis and dependent on the y-axis, just like y is equal to mx plus c. Now, next slide. Just see in this slide, what I have shown, N is on the top, you will see thickness is less in the micrometer, and P is at the bottom. Depletion region is between two material, and this depletion contains the neutralized electron and hole. This thing you have to keep in mind. Now, the H nu is the photon. Since N is the conducting material, transmitted material, thickness is less, resistance is less, so it is transmitted to the N material, reaches to the neutralized region, that is called the depletion region. And once this H nu has the higher energy in comparison to binding energy of electron and hole, as I have explained you in the case of H2O, their photon energy was much higher than the binding energy of the electrons and hole. Similar way, here also the photon has much energy than the neutralized electron and hole. So what will happen? It is, in other words, it is called photon is bombarded in the depletion region, and due to this energy bombardment, the electron hole are separated. जैसे कि आप भीड़ में जाते हैं, बम फटता है तो आदमी इधर उधर भागते बड़ी तेजी से. Similarly, it happens, but here it is electron and hole. Here it is a very, very important role of this phenomena. Why? Because if electron is created, so question is that which direction this electron will go. As I explained you earlier, the N is a conducting material, thermal resistance, electrical resistance is less. P is a insulating material, thickness is more, the resistance is more. So what will happen? Electron will start moving from through N. Just like see, it is just different in the case of earlier cases where I've said that depletion is about created, electron moves from N to P, but here from P to N. That means the direction of the current created by the photon is always opposite to the direction of the electron created by without illumination, because this is referred as with illumination and earlier case was referred as without illumination. So in this case also we can have forward bias, reverse bias, and also we can have a IV characteristic. Just see in this figure, the IV characteristics has shifted below the 0 point. That means why? Because here the current direction is always opposite to the current created without illumination. That means this curve is like this. Now, it is referred as solar cell. Why? Because PN junction generates the electricity. It acts as a cell, positive negative terminal. Solar energy is used because it is called the solar cell. Sometimes it is called the photovoltaic effect. Why? Because photon has responsible to create the current produced in the PN junction. So photovoltaic effect and device is known as solar cell. So definitely this will have one solar cell, will have current and voltage, which I will discuss later on. But for time being, just see when this curve is reversed. Just see this curve is reversed, then it takes off this form. Just see. Why current has been positive? Because current is never, power is never negative. But you know, the power is product of the current and voltage. So this curve is IV characteristic for solar cell. But this curve, if you just analyze in detail, so what we found that when the voltage is 0, the current is known as short circuit current. But when the current is 0, it is open circuit voltage. So in this IV curve, but if you have a rectangular ISC and VOC, this is a rectangular. Area is ISC into VOC. Just see here I have used IOC into VOC. This is very, very important. And the IV curve is this. For different I, different G, if you plot the power on this, so power curve comes like this. That means the voltage at which there is a maximum power known as V maximum, and when there is a maximum current corresponding, it is I maximum. So you can have I maximum and V maximum, it is in the rectangular area. So ratio of this to this is known as fill factor. This is a very, very important parameter, and generally manufacturer provide you the fill factor. And then how you can define the fill factor? Fill factor defined as the sharpness of the IV curve. If this point coincides with this, then the fill factor is 1, which is next to impossible to have the fill factor 1. So it is always less than 1. Why I am giving this definition? Very, very important. Because if you have any PV module, you can very easily measure the ISC, VOC. But if you know the fill factor, you can always find out the maximum power from any solar cell. But in this case, you will remember that the voltage is always fixed. The current is varying with the solar intensity. So you have to be careful about when analyzing the any phenomena, any performance or characteristics of the solar cell. Just see. Now there are different generations of the solar cell. I will not go much in detail. I will only concentrate on the crystalline synchron solar cell. Amorphous synchron solar cell, polycrystalline solar cell. And all these efficiencies which you are showing in this transmission is in a standard test condition. Because what is happening in the earlier, that every country who are manufacturing the solar cell, they are saying my efficiency is more, my efficiency is more. So the international committee decided nothing doing. What you have to do? You have to prepare a simulation lab where you create an intensity of 1000 watts per meter square and surrounding temperature 25 degrees centigrade. Under that condition, if you predict the solar cell efficiency, that will be compared. So generally, you will find that the people might have said that they have installed 2 kilowatt solar system, It is actually under standard test condition. This I will discuss later on. And now I will move to the another part. Just see. Each solar cell, generally, it is very big history, and then it is called the pseudo solar cell. So in this case, one solar cell gives roughly about 4.13 ampere current, and the voltage is roughly about 500 millivolt. If you calculate power is very, very small. So what happens? So if you want to increase the voltage, what should be done? The solar cell should be connected into series. So the current will be same, voltage increase. So generally, there are 36 solar cells which is connected in series, and it forms one module of 75 watt peak. Nowadays, you might getting, you can say 300 watt peak and 350 watt peak. Then you can get more than that. But the basic thing, the handling of the problem. Initially, if this solar cell effective area of 0.6 meters square contains 36 solar cells connected in series. So even if you want to increase more voltage, you can again, two modules can be connected in series. If you want to increase current, then you can connect in the parallel. So series parallel combination is referred as array. But I will first go the fundamental principle of this. So what happens? Actually, on the top there is a glass. Why glass? As I mentioned, that glass transmits all short wave radiation. So what happens? There is a top glass, and this is the tender. It is insulating material, light structure, and process is that the first tender is on the tender there is a ethyl vinyl acetate was, it is a gum. Of the same size, it is pasted on that, and on that EVA, the solar cell connected in series was pasted, and then glass cover was set. So sandwich. I am explaining in a very simple way, but it is not as simple as you are explaining. There is a technology which is used to make a sandwich of the solar cell between the glass and the tender with the help of the EVA, so that there should not be any air bubble left in between. And then there is a framing all the sides, so the air should not enter. Then it is called one module. And in this case, you can get 20, you can say the 18 volts, you can say this voltage, and roughly 4 ampere current. If you multiply it, it is roughly about 72, 73. But 75 watt peak module was first invented. But here, I want to explain you what I said earlier. Here also what happens, hello,
Kindly switch off the microphones, please.
hello.
Participants, switch off the microphones, please.
Sir, template ಅಂತ ಏನಿದೆ ಕಳಿಸಿ ನೀವೇನು ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಇದೆ
See, here
Prashant,
I am
participants.
Prashant, kindly mute your mic. Prashant, Risha ma'am, can you mute it?
Yes.
ಸರ್ ಪೇಪರ್ ಮಾಡೋಷ್ಟೆಲ್ಲ ಕಂಟೆಂಟ್ ಇದೆಯಾ ಅಂತ ನೋಡ್ಬೇಕು.
I request all participants to listen. Hello, I request all the participants to listen me carefully to understand.
Ma'am.
Remove him from the meeting. Risha ma'am, remove him from the meeting, please.
Okay.
If you cannot mute him, you remove him.
Ma'am, can you tell me from where do I remove him?
Click on the 3 dots, go to the people,
Yes, then.
remove the participant, it is there. Or mute him.
Actually, it's not showing here. Yes, I
ಅದೇ
will.
ಯಾವ್ದಾದ್ರು ಪೇಪರ್ ಬಹುದು ಲಕ್ಕಿ ನಂದು ಬಂದ್ರೆ ನೀವು ನಂತರ ಅಪ್ರೂವ್ ಮಾಡು ಅಂತ. ಅದು ಎಡಿಟರ್ ಹಾಕ್ಬೇಕು. ಎಡಿಟರ್ ಈಗ
I got it.
ಪೇಪರ್ ಬಂತು ಅನ್ಕೊಳ್ಳಿ.
Hello.
Yes,
Sir,
sir.
sorry for the
Kindly.
disturbance, sir. You can
Yeah,
start again.
ask them not to, because this is the crux of the problem, which I will tell you that everybody can do the research also. So my objective is to
Yes.
how the research is done in this area. So because of that, basically I will started from the greenhouse effect and considering the photon. So just here, when I say it is a PV module, solar cell is sandwiched between the glass and the tunnel with the help of the EVA. So just say between two solar cells, there is a gap between that because the earlier the solar cell was not in a rectangular shape, it is of the pseudo shape. So in that case, what happens when the solar radiation, in short of the radiation, is transmitted from the glass, it falls on the N type of the solar cell, and then it is transmitted to the depletion region, and then the electricity is generated. But here it is very, very important part. If during the peak time, like noon time, the photon has a maximum energy. So what happens? There is a maximum creation of the electrons and holes in the depletion region of the solar cell. So in that case, what happens? If there is excess electron generation, what happens? The electrons collided to each other. And once it is collided to each other, then there is not a smooth movement of the electron, and the current is affected, and hence the power is affected. That is the crux of the problem in the solar cell. What we have done. So what is the solution? That if the temperature of the depletion region is reduced, the collision effect will be reduced, and there is a streamline of the electron flow will start, and the current will flow, and the maximum power will be there. So this is known as the opaque PV module. Why opaque? Because at the back of the solar cell, there is a tunnel which is opaque. Now, TEL is one of the manufacturer of the PV module. So, also nowadays they are making the opaque PV module, but they have done the experiment on the semi-transparent PV module, means they have replaced the tunnel by the glass, and they found that when the tunnel was replaced by the glass, its electrical efficiency increased. But we were not able to understand why it is happening so. And this thing I am going to explain you, because we got the PV module opaque and a semi-transparent, similar size, similar rating, similar performance, and we did experiment at IIT Delhi, and we reached how this semi-transparent PV module is better. Just see. Just see here, in place of the teller, the glass was teller was replaced by the glass, which is also transparent. And just see here, earlier also the solar radiation falls on the solar cell. Yes, number of the solar cells same. In the earlier case also same. In this case also same. But the difference was that when the solar radiation falls between the two solar cells, in the earlier case, it was blocked between the glass and teller. But here, it is transmitted from one side to the other side. This indicates that the solar radiation trapped between the glass and teller, in the case earlier one, was more than in the present case. So what happens? The thermal energy in this case is less than the thermal energy in the case one. So what happens? The thermal energy is less, the temperature of the solar cell in this case is less than the earlier one. If temperature is less, collision will be less, current will be, electron flow will be streamlined, and current will be more. That means we found that only because of this phenomenon, because of the temperature effect, the electrical efficiency of the semi-transparent PV module is more than the opaque sample. And this semi-transparent PV module has many applications in the building, greenhouse, dryer, pumping, everywhere. So one by one, I will discuss how this has its application in the many cases. Anyway, this is now nowadays you can have the rectangular type of the, you can say this solar cell, and you will find that if the solar cell is joined together, you will not have the space. So all the solar module will have the opaque PV module. But even there is a gap between the two solar cells, and the glass has been used, it's called the semi-transparent. Now these are the, you can say this another type of the multi-crystalline. This is the thin film. The advantage of the thin film is that the thin film can be accumulated at the metal sheet also, glass sheet also. When we made on the metal sheet, it is a flexible in nature. So nowadays you might have learned the rules of E-Rexa roof is made of the aluminum-based thin film, or even the crystalline-based solar cell. Now these I think these are the things I have already explained you, that packing factor definitions and current, voltage, standard test condition, all these things. Now just see here. We have used this formula given by the Scott and the Evans, temperature dependent electricity efficiency of the PV module. Just see here, TC increases, solar cell temperature increases, efficiency decreases. This is a well-known formula. We have used many times this formula in our papers on the various photovoltaic and thermal integrated systems. Now, I'll just show you this. These are the application of the PV module, and these are the application of the semi-transparent PV module. From the figure, you will find there is a similar, but the phenomena of the semi-transparent PV module, when used in the water heater, air heater, building indicated PV system, daylighting, while this opaque cannot be used for the daylighting system, because for the daylighting you may need the solar radiation transmitted from outer side to inside room. And also this is PVT greenhouse. Here you see PVT greenhouse. Here you cannot see the PVT greenhouse, because in PVT greenhouse we have the direct drying and the indirect drying, both to make the quality of the product very good. These are, you can say, the results which have not been much detail from that. These are again, just see, these are the comparison. The red one is a semi-transparent, and there is the opaque PV model. These are the different. You can find out the semi-transparent is always better than the opaque. Now, first I have shown you that semi-transparent PV module is having the higher electrical efficiency than the opaque PV module. One, I say the opaque, that means the base is the tubular, and one I say semi-transparent base is the glass. Then we started, is there any possibility of further increasing the electrical efficiency of the semi-transparent? So what we did experiment. I will summarize. We have considered the opaque and the semi-transparent both, and we have flown the water over it, and to just see whether the semi-transparent is further increasing electrical efficiency. Yes, we found yes, because the operating temperature of the semi-transparent PV module in comparison to the without water flow was lower than the without flow. And we found that the electrical efficiency is further increased. Then question comes, is there again any further possibility in addition to water flow that electrical efficiency can be increased? So what we did, we make a duct below the, you can say, the semi-transparent PV module, and you did experiment with the air flowing and the water flowing over this, and we found that electrical efficiency further increased. Then question comes that whether the increase in the electrical efficiency is beneficial or cost effective with water flow and the air duct or not. So it totally depends upon the application of the electrical energy and application of the thermal energy. If thermal energy is used for drying purpose, yes, it can be cost effective. If it can be used for the space heating, like cold climatic conditions, where fossil fuel is used to heat the water, yes, it is economical. So all these things I will discuss later on. So I will skip. This is the semi-transparent. Earlier one was the opaque. Yes, it is with duct. Also, this duct. Now it is thin film, as I mentioned that on metallic sheet, the thin film was coated, and generally this type of structure is used on the building, airport. So actually, thin film technology is not available in India. It was basically the German people who came here, donated us, and did the experiment with water flow and without water flow, and we found that with water flow, the electrical efficiency is more. Now, I'll come on the application of, you can say, PV module. And one of the most application was that water heater. Now, those who are working in solar thermal technology, so you might have found that the solar thermal technology works under the natural mode of operation and force mode of operation. And one might have concluded that the all solar thermal technology is always gives better efficiency under force mode of operation. But the natural mode has their own advantage and disadvantage, and the force mode has their own advantage and disadvantage. For example, water heating system. I will first consider the natural mode. In a natural mode, the limitation is that the storage tank should be above the upper header, and the connection just has been shown to you in figure. And the disadvantage is that there is a stratification of the water column in the tank. Earlier, the tank was supposed to be vertical, but to avoid that stratification, the tank was made horizontal. But even then, there is a stratification between bottom and top. If suppose you are using the water heater in the room tank, and if you are using the evening tank, obviously you will not get maximum water heater. But if you are going to use early in the morning, then the stratification is minimized due to convection from top to bottom, and you can get the uniform temperature. That is the disadvantage of this. But advantage is that you don't require any electricity to operate. That is the advantage in that favor. Also, the maintenance cost is less because if the motor is not working, there is no need of maintenance of the motor because it will be. But in the force mode, the advantage is that there is no need to put the storage tank above the upper header, because the thermocycling system can be better for a domestic region, for the 500 liter, 400 liter, something like that. Because this natural circulation water heater should be put on the roof of the building. So for smaller capacity, roof of the building can sustain this load. But when you go for 4,000 liter capacity, 5,000 liter capacity, in that case, civil engineer will never allow you to put 5,000 liter capacity tank on the roof, because they will say that roof design is not made for this much load at a particular point. So in that case, what will happen? The storage tank should be put on the below the ground floor, and the collector will be placed on the rooftop, because collector is a lightweight structure. So in that case, no natural mode of operation will work. So what will happen? You have to only allow the force mode of the operation. And force mode of operation means the electricity should be there during the daytime. And if someone might be remembering that in IIT Delhi, when this natural circulation solar water heater was installed on the roof of the hostel, then it was found that it has not worked, because when the electricity was required in the daytime, there was cut-off period. And also the water supply should be continuous to the system. And also the water supply was not continuous system. And because of that, the natural circulation water heater was installed on the Shivalik hostel was not worked properly. But after that, when the water heater installed in the rest of the water was in the force mode of operation, and there was a standby tank so that the continuous water supply should be there, and that system worked quite well. So now question comes in our mind that suppose water is available, but electricity is not available because the electricity is not in our control. So what we did, we simulate experiment on water system by using the semi-transparent PV module, which I have shown to you earlier, that has a high electrical efficiency. So just see, there are two flat plate collectors. In one flat plate collector, this is the, you can say, the lower portion, we have made the semi-transparent PV module integrated. So what happens? This integration has two advantages. First, it provided the DC power, so the DC motor will operate. Second thing, the solar radiation falling on the non-packing factor area is directly transferred to the absorber, so thermal heating is there also. That means by integration, we are going to get two types of the energy, electrical as well as thermal. And because of that, it is called photovoltaic thermal water system, PVT technology. So when the semi-transparent PV module is integrated to provide the electrical as well as thermal, in addition to that daylighting, it is referred as photovoltaic thermal system. And the whole system has been referred as photovoltaic solar thermal solar water system. Just see here, the other advantage of the force board is that collectors can be connected in series, but in natural circulation, collectors cannot be connected in series, so there is a limitation of the upper temperature. So advantage of the force mode is also that collectors can be connected in series, because in large scale, you cannot go all collectors connected in parallel. So some parallel, then series, parallel series. This is the combination on which 5,000, 6,000, 10,000 watt system can be connected. And the electricity generated by PV system can be used for the DC motor. Now here again, when you are doing some research, so there is a lot of comment coming from the, you can say, that's a reviewer, and if you want to get your paper published, so what happens, you have to certify that. So one of the reviewers says that why you are putting glass below, why not outside? Now, as you understand that in our country, it is very easy to say the glass should be up and see the comparison. So we mentioned that, sir, due to the financial constraint, we will not able to do the experiment this one, but later on we'll do experiment. So theoretically we found that why not put upper? Because if you put upper, the operating temperature becomes high, so electrical efficiency is less. So it is always better that the PV module should be at lower end. But here in this case also, there was a comment that why not half of the PV module should be on one collector, half of the other, so it looked nice. So we did experiment that one, because the solar cell manufacturer CL has agreed to provide the half of the capacity of the PV module. Just see here, because it is a toughened glass. So to cut the toughened glass is very difficult, as you know. But to cut the solar cell was very simple. So earlier case it was 75 watt, and this is the 35 watt peak. And just see, we have connected, and yes, it looks better than the earlier one. Now, again, when this paper was sent for publication, then another suggestion was that why you are covering half of the collector or 1/3 of the collector by PV, why not covering the whole? That is called the fully cover. So basically we did that experiment also. I don't know whether we have the slides or not. And in the solar cell manufacturer, just today, what we came to know, that if you are increasing the area of the toughened glass, and if you are not increasing the area of the solar cell, so for a given kilowatt hour, number of the PV module is more, the cost is very, very large. So in that case, we can have a combination of the PV module and then glaze, PV module glaze, then it will be the economical. Let's see. Actually, this is the, you can say this first photovoltaic thermal irritant system, which we get it done at IIT Delhi. And you'll find that there are two air ducts. And the beauty of this duct is that if you connect the outlet to the inlet, so temperature will increase. So here, it is a fully covered. Let's see, we have done experiment, the fully covered. You can see PV module. So in that case, when you are going to design any photovoltaic thermal system, so you have to respect the demand of the user. Whether user needs more thermal energy or more electrical energy, or combination of both. So accordingly that you have to optimize the parameter. So we have developed theoretical model of whole system which we have discussed, but it is very difficult to discuss the energy balance. But by using the energy balance, we can optimize whether your priority is thermal, means space heating, then accordingly the series combination, series parallel combination can be done. But when your priority is on electricity, then your priority will be different. Then your connection will be different. So accordingly, we can do all these things. Now just see this is here. You will also use 1 fan, 2 fan facility, increasing the mass flow rate and also storing the electricity in the battery, so it can use the night time. Just see here. This is the greenhouse, because this was earlier we constructed at IIT Delhi, and here all the cooling arrangement has been made. And for your kind information, the cultivation of the plant is very sensitive to the temperature, relative humidity, and the light for photosynthesis and the carbon dioxide level. All 4 parameters are very, very important to the greenhouse cultivation. That is called the microclimate greenhouse effect. It is not a global greenhouse effect. Because global greenhouse effect is with respect to the whole global phenomena, whole world. And when we say the micro means, it is a plastic or glass or any transparent material has the same property as the atmosphere. That means it transmits solar radiation, but after the photosynthesis, after the absorption, long radiation is exchanged, it is blocked. So the temperature is controlled. So what happens? We design this, you can say this greenhouse by considering all the cooling and the heating effect. But we have misting arrangement also, we have the deep irrigation also, we have the part cultivation, field cultivation. To operate and the cooling arrangement, just you have seen, to have the operation of all these appliances, we need electricity. So what we did, 2.4 kilowatt peak opaque PV module, we have integrated on the south roof. So in that case, what happens? A part of the solar radiation was converted into the electricity, and the rest is conducted below the PV module, which is used to heat the greenhouse space between that. And that space, inclined space, which covered the horizontal area, was used for seedling purpose. And after the seedling purpose, we can transplanted the plant, and we have the cultivation of the field and part. So this type of the greenhouse system is a self-sustained system, because even in IIT, when we are doing the experiment, there was a power cut between even peak time hours, between 12 to 2 hours power cut. And as you know that solar radiation is maximum during that period, and if there is no cooling effect, all the plants will die. So sometimes whatever you are facing, solve the problem your own way, as has not been done in the past. So this is called the photovoltaic integrated greenhouse system, where the electricity generated can be used for running the appliances. So if there is no grid power, it can work successfully. Now just see, this is another successful, you can say this application of the semi-transparent PV module. Semi-transparent PV module, again I am repeating, when the teller is replaced by the glass. Just it is a plastic structure on the aluminum frame. It is called event type greenhouse because the event type greenhouse means the area of the north and south roof should be same. Just it is like a house, as a railway house. So it is referred as a greenhouse. Since it is used for dryer, it is called for dryer. And photovoltaic thermal means it is photovoltaic as well as thermal. So here we have found that when this PV module was open, in the roof vent, so hot air can be escaped. So it can be referred as natural mode of operation because no force mode is required. But when it is closed, the fan is operated, then it's called force mode of operation. So we did experiment simultaneously. There was two on the natural mode, force mode, and we found that force mode was much better than the natural mode. Just see here. Here you might have seen the two fans. So it has a larger velocity. It is the lower mass flow rate. So I will tell you how this dryer works. Open drying is known to everybody. In open drying also, when the solar radiation is there, the crop absorbs the solar radiation, heated up, moisture content from the crop is evaporated. But if this evaporated water has a heavy structure, water molecules have the heavy, so it's sustained above the crop. So what happened? The evaporation is affected, drying is affected because the high relative humidity. Just like in monsoon season, the crop cloth takes more time only because of the relative humidity. But it is dry, then the relative humidity becomes low and the rate of evaporation is fast, drying is faster. So now you can see that in a natural mode, the vapor escape is very slow process. But in a force mode, the vapor is immediately transferred from inside to outside. So because of that, the drying in the force mode is always better than the natural mode. See here we have taken the mint, pudina and other things to dry out. Or there was a case arrangement. We can dry 9 crops at the same time, but we have not done 9 crops at the same time. We have taken one, and we dry many dry and then make the powder. So since it is a pudina and dhania, so moisture content is maximum. So there is a fast evaporation, means fast drying. Drying time is also important. So in that case, you dry it, make a powder, you can store it. And just like making a pouch, one can do the entrepreneurship also by using such technology. Nowadays, the drying is done by using the fossil fuel electricity. I think it is environmentally not friendly and also it is not good for the climate change point of view. So because of that, the government, all the government, mostly in the developing countries, giving importance to the renewable energy for two-day activities. So in another way, you can say that food processing can be operated by at least renewable energy. Or you can at least use 50, 60, 70% energy and then go for the conventional drying. So you can save the fossil fuel. Now just see. When we are using ITC, criticism is a very simple phenomenon. Anybody can criticize it. So we have also faced similar thing in IIT that people say that दीवार की पुदीना सुखा रहे हैं, इससे क्या होगा, ये तो उसी तरह से दिया जाएगा. Then we decided that we should use, you can say, grapes to dry out. But when you go in the market, you can get the different type of the grapes. So just see, you can say there are 3, 4, 5 classifications we made of the grapes, and obviously we dry it and see the different color. And for kind information, color of the grape plays a very important role. Not only grapes, color of any dry product plays a very important role. And in the market, you have the maximum return value in comparison to the color. As you know, color gives a choice of the customer to purchase even in the higher cost. Let's see, this is another type of the dryer, in which this is the solar cell in the early days was a circular type solar cell. So in that case, what happens? Wastage of the material was much more. Then it comes on the pseudo type. Even then there was a much losses of the solar cell material. Then it comes on the rectangular, where there is not loss of any solar cell material, because to get the solar cell material is a very long process. I am not expert on that, but the wastage of the solar cell material makes the solar cell costly. So nowadays we are having the rectangular type solar cell everywhere. Just see, this is an end view of the, you could say, this solar cell dryer. And here I want to tell you one thing very important, that any solar thermal devices, not only any solar thermal devices, but any devices. For example, we are designing a building and we are using the aluminum frame. But as far as the screw is concerned, if you are using the screw of the iron, so what happens? The life of the iron screw due to the dusting goes damaged. And then to replace this, it becomes very difficult for aluminum, because if your aluminum has a certain screw, so you need more diameter. So what I will suggest, we did in the Banaras, that the material of use for any component of the system should be same. And glass and aluminum don't have the fusion factor. So the glass and aluminum, for aluminum, every material should be of the aluminum, not of the iron or other material. Yes, this is called, you can say, this PVT mixed mode dryer. Why? Because the solar radiation is this is the air heater, this is the air solar PV module. The electricity is generated to operate the fan. So crops are kept here. So it is not directly heated. It is heated by the hot air mostly, and some partly direct gain. So there are two types of the gain in solar thermal devices: direct gain, indirect gain. Like in window, using the glass, so through direct gain the solar radiation comes, but if to the opaque wall heat is coming, it is indirect gain. So since in this case we are using direct as well as indirect, so because of that it's called mixed mode dryer. Just see, this is, you can say, this another type of the, you can say, the dryer, where it is working since 2012, and except the fan, we have not replaced anything in this case. When including the tray was the aluminum based wire. So once you are using the similar material for fabrication, the life is new, because maintenance, if you go for the life cycle cost analysis, then it is in operation maintenance plays a very, very important role. And in this case, even you can say this, if you want, particularly when you go in the rural area, and if you want to change a screwdriver or something like that, a tray, it is very cost effective. Not cost effective. So in that case, if the similar material is used, so the maintenance will be less, so it will be economical. Now, this is a concept which we have submitted a project to DST, and sometimes I receive lot of queries about the submission of the project and something like that. So unless you don't have the new idea, new concept, even when you are in IIT, you face a lot of problems. So unless you don't have the idea, it becomes very get to. So now I'll just see. I have just shown the working principle of the, you can say, this PVT dryer. I'll just show you. Just see, here is a fan at the top to remove the moisture from inside to outside, so the relative humidity will be less and drying will be faster. Actually, what we here is the Bernoulli's theorem, that if this cross-sectional area is reduced to small one, so what will happen? A1, V1, A2, V2, the velocity of this air will be increased. And if velocity increase, though, we thought that is there any possibility of using the micro wind turbine? So what when the wastage heat, hot air, can be used to further generate the electrical power. That was the concept. It is not easy to convince the new concept to everybody because there are many questions coming that a small velocity, how you are designing the micro wind turbine, this and that. But we have said that we have not got for this. We are going to implement this for a bigger project, which I will show you later on. Now, another application. Now the wind turbine effect we will discuss later on. Another experiment was a solar distillation system. And as I explained you that solar distillation, the top is a solar distillation unit, glass is there. And in this case also, the solar radiation, long wave radiation is transmitted by the glass and it is finally absorbed by the water mass and basin. And ultimately water gets heated. And as you explained that when the water temperature becomes higher than the water glass temperature, so evaporation takes place. Just like open cycle. Just assume the sea water, how the evaporation takes place. Evaporation takes place only when there is a temperature of the water not higher, lower, but relatively should be higher. It is an open water cycle. It is a closed water cycle. In a closed water cycle, our relativity is 100% inside enclosure. And that vapor is condensed on the inner surface of the glass, and since it is inclined, it will trickle down and collected. It is going to be pure distilled water, and which can be made equivalent to the potable water by mixing the minerals or mixing the brackish water or suitable water. But in this case also we found that sometimes if there is no external heat is fed, it is called the passive solar still. To get the higher, get the more water, you have the active system. Active system is external heat should be provided to the basin. So there is a fast evaporation. And in that case, as I mentioned, the similar collector configuration was integrated to this under force mode of the operation, and connection was made in a series. And we found that the yield of this solar steel is much higher than the yield of passive solar steel. Here I want to make a clarification. The efficiency is a different factor and the yield is a different factor. Efficiency totally depends on the operating temperature, just like a yield. So for example, active solar steel operating temperature is maximum, then the electrical efficiency or thermal efficiency is lower in comparison to passive solar steel. So you have to be very careful that whether users are interested in the yield, because they are always interested in the yield. They don't bother about what is the efficiency. Efficiency जो खाना नहीं खाएंगे ना पानी पिएंगे, वो yield से ही जो है खाना खाएंगे, पानी पिएंगे, खाना बनाएंगे. और my advice is that the area in our country, you will find that there is maximum underground area which is polluted either by arsenic, either fluoride, either the hard water. So this device should be used only for this type of underground water, not for the sea water, because sea water has a salinity of more than 45 to 50,000 ppm. And as I mentioned earlier, that if you use this saline water for distillation purpose, the scaling will be faster, maintenance is maximum, there is chances of breaking up the glass, otherwise you have to make some other alternative. So my advice that it should be decentralized way, but if you are going to for a centralized way, you have to design whole system by keeping all maintenance and input parameter, like whether you want to saline water or brackish water or hard water or fluoride water, all these things you have to take into account. Just see, here just see we have repeated experiment by having just see here there is a deterioration of the solar cell because it is not at a large scale manufacturing, small scale. And if the packaging, solar cell and assembly is not properly packed, obviously due to the water content, it will be destroyed, deteriorate. So just see here and here, this one is as good as the earlier one, but this is not good. So it is very easy to say that we can train the people to make the PV module locally, but as far as life is concerned, when it is properly packed, its life can be 35 years, 50 years. But if it is not like that, its life will be much, much less. And if anyone is interested, they can go to Seer and they have the rooftop. And in 1973, they made a solar cell. Just say, efficiency there can be down, but still it is giving electrical power. So now it is very important to the newcomers to find out at what time the PV module should be replaced by the new module, and also how the junk PV module can be disposed of, can be reused for that. Otherwise, environmental problem will take place. So all these are the new area of the research. Nowadays, government is giving importance. जिसे जंक फूड बोलते हैं, इसे जंक इलेक्ट्रिकल गुड्स बोलते हैं, तो इसके लिए आपको बहुत ध्यान में रखना पड़ेगा। टाइम जरा हो तो बता देना रिसा जो है। हेलो हेलो,
नेक्स्ट सेशन 2:30 को है। हेलो सर।
हाँ अकॉर्डिंगली आई कैन। हाँ हेलो हेलो, हाँ बोलो।
Yes sir, next session is at 2:30. So we have sufficient time, sir.
There is no problem. Okay. Then I will be very slowly, and then I will talk to other people. Right?
Okay, sir.
Now just see these are the actually this in our country. When I say that don't take a specific states or other things, developing countries means our countries are the developing countries and developed countries. So there is a basic difference, this concept of the developed countries and developing countries. If you go in the developed country and if something new technology comes into the picture, they always try to adapt themselves. They don't expect that the government should give the subsidy or the government should give some financial help. Financial help is different than the subsidy. Unlike our country. In our country, always you expect that the government should give the subsidy, then we can use it. I will give example. Just see these three figures. All three figures are the historical figures. This is the tower. Just see. You will find any book, any Google search, everywhere you will find. ये इंग्लैंड में है जो all the walls here have been used by the semi-transparent PV model. Now see, economics will come later on. अब हमारे problem, what we have the problem, we immediately ask what is the economics. If your system is successful, economics will come. Demand is more, economics will come. Just like mobile. In our time, in 90s, to have a mobile was very this luxurious thing. People used to put the mobile in the hand and so that they are having the mobile. Charges was very high. But when there was a demand, just say, what is the situation of the mobile today? But purchasing the mobile, nobody say that you give me, you can say this subsidy. So unlike our set of minds, the developed people, once semi-transparent PV model was developed there, they first used in a CIS tower in Manchester, in England. Yes, because solar radiation is not maximum on the wall, so it is not advisable to use the PV module in the wall or window. But it is a historical picture, and because of that, now we are discussing. They might have invested, they have not got benefit, but the popularity, now this name is also like to be used to be as a just reference point. Now just see second in between. In Europe, most is the cold climatic condition. So one thing here I want to tell you one thing. To design a building for uniform climatic condition is easier. And fortunately, our India has all the climatic weather conditions of the world. Like if you go Leh, you get the European concept. Srinagar, northeast. Maximum you can say you require the heating. So in the Europe, what happens? They were using Bukhari. Bukhari means biomass they are using, petroleum they are using for heating the room. And once they realize that this functioning of the fossil fuel is not going to be lost longing. So what they did, they just use the PV module on the roof. They integrate. Also reduce in this case. That means the heating is inside. So losses will be less. Second advantage, they are getting additional electricity for lighting and operating the electrical gadgets. So without asking for the economical viability of the OPEC PV module, they have just integrated and just see how smooth it is look like. Look like very nice. But they have not used the PV module on the window because they were knowing the maximum solar radiation is available on the horizontal surface on the roof. So because of that, they did it. Now, come to the extreme right hand side configuration. Just see, as I have mentioned you, that the semi-transparent PV module has high electrical efficiency because of the low operating temperature. So, another community, it is a community center, they adopted semi-transparent PV module as a roof. That means the semi-transparent PV module they have integrated into the roof. Just see, what is it giving? It has a 3 applications here. First application, higher electrical efficiency. Second, daylighting, which is also equivalent to the electrical power. Third, the thermal energy which is coming through non-packing area or back of the solar cell, they are using for the space heating. So the question comes, if a unit or if a system has a more than one application, economics will be that. But what care should be taken that since it is a cold climatic condition, so the cleaning of the glass is minimum. That means, unlike our cases. So if you made an arrangement, in our case, if you are going to make an arrangement of the cleaning arrangement, because our region is the resting period. And another important point thing I want to tell you, that our climate condition is divided in 6 climatic zones. Just like Bangalore, it is a moderate condition. Neither require heating, cooling. So to design the building for climatic condition of the Karnataka is very simple, Bangalore, Mysore. But if you are going to design the building for Leh condition, yes, it is also simple because you want only heating throughout the year. But if you are going for Srinagar, the maximum heating is required, cooling is less required. But if you go for of northern region or northeast also you may require heating and cooling both. So the building should be designed from that point of view, and in that case you have to see whether heating is more required or cooling is more required. As I understood, in northeast region, heating is more required than the cooling. Just like northern part of the country, like Delhi, Uttar Pradesh, Madhya Pradesh, you require more cooling than heating. So the building should be designed from the cooling point of view. And just see by why I am referring this figure, that if you require heating maximum, then the exterior wall which facing the sun should have a maximum double glazed windows. Be careful on that point. But if you want to design the building for the composite climate where cooling is maximum required, so for kind information, the single glazed window should have a minimum exposure of the solar radiation. Because once you are using the glass, it gives maximum direct transmission of the solar radiation. As I mentioned, that the glass transmits all sorts of radiation. And once it is transmitted inside, so it will be heated up and heat cannot go escape outside. So you want to cooling on one hand, then you are heating on other side. So, but unfortunately, what is happening? If you just go there, now another part, they are using maximum glass to the exterior because it look nice. तो ध्यान रखिएगा, जो चीज देखने में अच्छी लगेगी, जो चीज खाने में अच्छी लगेगी, वो शरीर में और पॉकेट के लिए बड़ी भारी पड़ेगा. So you have to take into consideration this point that when you are using solar energy, be careful. बहुत अच्छा लगना अच्छी बात नहीं है, क्योंकि comfort is more important than looking. Now just see. Just see here, the PV module has been used for this petrol pump, here shops and shops. So it acts as a roof also. Nowadays in our country, yes, different petrol pumps have the standalone system, but it is separately, not integrated to the roof. But it should be integrated to the roof. Then you can ask question, sir, what is the advantage? So in that case, you don't require additional land. And in our country, land is a very, very rare phenomenon because we use land for the agriculture purpose. So when it is called the roof integration of the solar system, and this is a self-system, because again here I want to tell you two things. One is a grid system, one is an off-grid system. Grid system is when in the grid, if you have a 24-hour electrical availability, then what you can do, you can install on your roof PV system and connect to the grid. So what will happen? If you are not in a house, so power generated from the PV system is first transferred to the grid. And when you want to use it, you can take it. Export and import system is there. But for export and import system, which is generally referred as the grid system, it should be continuous power supply availability on the grid. And unfortunately, in our country, except few places like railway, like PMO, CMO, or Ministry, Delhi, Bombay, electricity is not always available. But at least electricity should be available during the daytime, because you are getting solar power from PV during the daytime. And suppose you don't have grid power in Balliyan, during daytime you don't have grid power. So what will happen? If you integrate it to the grid power, our solar will be wasted. There is no use of that. But during the daytime it is available, so we can export and import. And what we can say that even if you use the minimum electricity, so there can be excess export of the power which can be used later on when we desire. So there is a balance sheet in the electricity department that Mr. So-and-so exported this much, imported this much. So every month you will get the balance sheet. So just say, by seeing all these advantages, people have integrated on the roof. But here is, you find that petrol pump people, they are using a separate space. But my advice that if you integrate, so it will be nice, it will not require space. Otherwise, in a cost analysis, the land cost should also be incorporated. Because land is not free, land you have purchased, and cost of land is increasing very fast. So to avoid economics of the grid system or off-grid system, you should always prefer to have the more application than only power generation. Just here, this is a industry they use on the wall, but at that time, the economic viability was not investigated. One main purpose was to avoid the fossil fuel by using the renewable energy. अब देखिए, just say the people who have integrated PV system on their roof, जिसको खपड़ेला मकान बोलते हैं, तो इस तरह के हाउसेज नॉर्थ ईस्ट में बहुत होगा, जहां से हमारा ख्याल है. They are not rich, but they are adopted. But if you ask all people, they say that they don't have money, they don't have this, they need subsidy, they need this. Even those who can afford, they don't use it. So that is how I have said these houses are self-sustained as far as lighting is concerned. Because here it is very important to explain the energy security. Energy security means definition changes time to time. When this system was integrated on the building, the energy security main purpose was light. Because in developed countries also there is a remote area, there is no electrical power there. So they integrate and they have the light and they feel the comfort. And as a human being, we need light first, then fan, then cooler, then AC, then so on, so on. So if you need more electrical power, high grade power, it is called the high grade energy. Thermal energy is a low grade energy. So suppose here I want to mention you that if you, from PV system you are getting electricity and you are also getting thermal energy, then any can ask you, sir, what is the total energy? So generally what happens, people say that add electrical energy to thermal energy. It is not correct. Why? Because thermal energy based on first law of thermodynamics, electrical energy is based on second law of thermodynamics, Carnot efficiency factor. In second law of thermodynamics, operate at very high temperature, 300 to 400, 500 degrees centigrade, just like a steam engine. But first law of thermodynamics operate below 100 degrees centigrade. So then what is the solution? Then your thermal energy should be equivalently converted into, जैसे suppose करो gold and silver है, दोनों का कास्ट मिला देंगे तो काम नहीं चलेगा. सिल्वर को इक्विवेलेंट गोल्ड के बराबर कन्वर्ट करना पड़ेगा, तब टोटल कॉस्ट आपका इवैल्यूएट होगा. एंड वाइस वर्सा, गोल्ड टू सिल्वर. तो सिमिलर, electrical energy is the gold and thermal energy silver. So thermal energy, there is called the exergy. There is a formula for exergy. If you use that exergy to the first law of thermodynamics, this becomes upgrade, उसकी value low हो जाएगा. So then it is called overall exergy efficiency. Then if you want to convert electricity into thermal, so you know power plant conversion efficiency, you divide it, then thermal, overall thermal performance. तो सस्ता चीज खरीदिएगा तो ज्यादा मिलेगा, महंगा चीज खरीदिएगा तो कम मिलेगा. So this is the same way one can explain the phenomena of the exergy, high grade energy and low grade energy. In a building, we are using low grade energy as well as high grade energy. अब देखिए, now actually when I was in IIT Delhi, I got educated from Banaras University. So those who might have been Banaras University, old university, maybe Allahabad University, or even in Silchar, you can see the old houses of the DM, other things. So you may find what I am trying to tell you. That for thermal comfort, there is a concept of trumbe wall, thick wall. The thick wall is not generally used for the winter, it can be used for the summer also. So thick wall means, in a technical term, the U value should be very, very small. That is the one concept which has been installed in this building. Because you people are very young people. So when I was also in IIT, so we found that senior people, when they retire, So what happens? Their whole established lab is renovated by saying that it is outdated and obviously they create new. When they retired and new generation came, they again they said it is outdated. These are fact situation everywhere, not in IT. Everywhere. So I was keeping this in mind that when I also retire, then what we have done in Solar Energy Park will be dismantled and it happened like that. So I don't have any regrets for that. But what I did, I purchased a land in Banaras and we decided that through a society that is called the Bag Energy Society, and the member in the Bag Energy Society from IIT Bombay, Professor J.K. Nair, and Professor Bisra, IIT Unti, and Professor Imran Khan Jamia, and all my students were the member of that society. And then we have developed energy efficient building. It's a 4-story building, ground, earth shelter, you might have heard your name, earth shelter, for cooling purpose is used. Then the first, second, third floor. And just say we have the Roshandan for daylighting in each floor. So for kind information, when you enter in this building, so you will find daylighting from basement to top. Then question comes, how you get the basement daylighting? So the 2 wind towers. First in between and second on the south direction. And purpose of the wind tower is provide the daylighting as well as it acts as a extraction of the hot air from inside building to the outside. Also have the cross ventilation. Whatever you can think over it. We have the, and orientation is the north and south. The north and south if you have, so south direction where the minimum solar radiation. So this building is from cooling point of view. And we have made this under the Bag Energy Society. And the building was named after our teacher, Professor Mahendra Sita, the Soda Bus Energy Complex. So I will show you some view of that. Just see. This is the basement. And this is the east side. We have Roshandan. So the half of the portion of the building is daylight availability during the daytime. Now this is earth shelter. So from here it is 75% is underground, only 25% top. Height is also kept as a 12 feet. So the height plays also very, very important role. Also here we have what happens, we have the covered side arrangement. The covered arrangement means it gives U value less. Now just see it is a under wind tower. So half a portion is delighted by the wind tower. Just see here it is covered and covered by the wooden frame. So we can keep the usable things, cloth, everything. So in that case, U value is reduced. So this floor gives the maximum cooling, let us say sometimes 9 to 8 degrees centigrade, low temperature than that. Because the earth temperature is always, underground earth temperature is 25 degrees centigrade or 29 degrees centigrade. When the outside temperature is 45 or 46, you may very comfort have a temperature of 30 degrees centigrade. And if you just turn the fan, you will feel the condition of air conditioned feeling. Yes, but in the winter, it is too cold. So in that case, the situation is roughly about a month, 2 months. You can use the convector. And in that case also, the heat is retained much, much more than online conventional things. Let's see here. Here, under wind tower is there and courtyard type situation. So the daylight is provided for all this. And this is a cross ventilation because we divided building the 2 parts. One part is this, another part is this. So just see a cross ventilation. So through cross ventilation, hot air is always escaped through the wind tower, both wind tower. Just see. And now just see. Here it is a first wind tower. It is center of the building. So in that case, what happens? We are facing a lot of problem due to the opening. Why? Because birds sometimes, monkeys sometimes come into inside the building and they like the havoc. To avoid that, we have green shade. And green shade means sliding window also. So the hot air can go up. But advantage is that during rainy season also the water doesn't come in the building. Protected from all these birds and monkey and other things, dust also. And the second thing is that all these walls are white. So the reflectivity is more. So the day lighting is reflected back into different room connected with these windows. So by all considering, the maximum daylighting saving is there itself. Now before that, I want to just tell you one thing. Oh, sorry. Yes. Here I want to forget to tell you, just say, here there is an inclined, you can say beams. You keep this in mind. Because once you want to integrate semi-transfer building, transfer PV module into the building, so you have to plan before. So it could be integrated to the structure itself. When the semi-transparent PV module is integrated into structure, it is called as building integrated semi-transparent photovoltaic thermal system. So it will provide electricity as well as thermal energy, as well as enclosed space can be used for sun bath, or you can use for the drying also. So it has a multiple application. So you can get benefited out of that. This is the lamination of all these things. Now just see. Now I will come, you can say the end of this thing, but I will also share without slide something which we have done in Bania. But concept is the same. Just see here. Here we have used the semi-transparent PV module. Just see here is a staircase. As I said you, because the limitation of the roof surface. So by using this, we can clean this, you can say this very easily. Cleaning is important because dusting reduces the performance of the electric person very sharply. And particularly in the summer, we need cleaning once in a week minimum. In a monsoon season, yes, you require only once in a cleaning because dust deposition is removed. In a winter also there is less maintenance, but in the summer you require regular cleaning, otherwise electricity production is very. Now question comes, to clean this, you can say area, you need a lot of water. Yes, we need a lot of water. One can say that there can be a wastage of the water. No. What we did, just see at lower end, we made a provision of collecting this clean water, this wasted water, and we have a rain harvesting system at the basement. So that water is sent to the rain harvesting. So the water level in the underground level can be maintained. And in that case, if you are having the boring, you might have heard that after 30-40 years, it is dry out, then you have the under boring. So in this case, the life of the boring can increase, maybe double, because the water which is used for cleaning purpose is going to be charging. So in that building complex, charging and discharging both have been taken into account. That is the first thing. And the second, you just see here, this is the second view. You just see the solar radiation from the white spot is transmitted because the glass always transmits short radiation. It will go inside enclosure, and inside enclosure it will have warm room. If this warm room is enclosed, so what will happen in the winter? This warm air is conducted through the roof to the second floor. So the second floor temperature becomes 2-3 degrees centigrade higher than the other untreated surface. So here we have 10 kilowatt peak solar system, and here I will realize one thing, that the multi-storage building we should not have rooftop integration. Why? Because limitation of the roof area, and if you are having the multi-storage building, the occupancy is more, demand is more. So because of that, by using this 10 kilowatt peak solar PV system, we are only meeting the 25% of the demand, and mostly used for the lighting purpose, fan purpose. We don't allow any air conditioner to operate on that. That is the one disadvantage of the system, that it cannot be used for the multi-storage building. Now, but if you consider sun bath, because in winter, if you consider, if you use floriculture, or if you can use for drying purpose, then it is most economical, because drying, sun bath don't require larger space. So it is very economical from that point of view. And our dryer, which I have shown earlier, is also, you can say, integrated into one of the tower. Second point is that, as I said, that we recommended that this enclosed space will be used for dryer. So what will happen? So we are going to use a big fan at the back of the system. So hot air will go down, go thrown out of the room. And if we can increase the velocity of the thrown air by using the Bernoulli theorem, so what we can do? We can have the wind micro turbine system. Actually, we made a micro wind turbine system, but it was very heavy. For kind of information, we were the physics background people. We are not much aware about the heavy structure, because heavy structure requires larger velocity. So now there is a scope that if you can make a light structure, micro wind turbine, I think it will be operated, and I will show you later. Now this is the view. I think it is not operating. I don't know how to operate it. Just see. Fan is just see on the top. So if one wants to heat the space, so there is a wind tower, and through wind tower it can be thrown into each floor. So there can be space heating during the winter period. But in a summer period, if this is blocked, so what will happen? All the hot air will be thrown out. So it will be cooling mode. In a cooling mode, drying mode, and as well as the electrical power generation. So if you consider all the factors into accountability, then the whole system can be referred as the. Now, one thing can be asked is what is the permanent status? Actually, this is due to this whole hostel was used for the accommodation of the girls' hostel while it was there. But due to the corona for the last 2 years, it was very difficult to visit there. Only there is one person who are maintaining somehow. But if you are not using the power, so what happens? Your battery, charge controller, everything got damaged. So now this is the situation. But as soon as you can say this, our situation improves upon, then I think we will be able to reactivate the whole system. So now, another things which I want to tell you that about my activity at Balia. We have just like a building integrated semi-transparent photovoltaic system. So I have already shown you the greenhouse And in that case, if roof of the greenhouse is integrated by the semi-transparent PV module, then we refer it as a greenhouse integrated semi-transparent PV module, GIS-PVT. And greenhouse is of the many types, so we have used the uneven type of the greenhouse system. And in Bania, we have the 30 kilowatt peak of different packing factor. And we have already constructed. This is the mission innovation project. This is the international project. And this project, the main objective of this main project was there is a lot of desert area which is not used so far. So what we have done, we have constructed this greenhouse integrated photovoltaic thermal system, GSPVT, for cultivation of the crop in a pot as well as brick channel, and also the electricity provided by that is going to be utilized for supply to the nearby school or also to run the electric vehicle like e-rickshaw. And second thing, also we are having the biogas plant, so the wastage of the vegetable can be used mixed with the cow dung, make the slurry and for biogas generation. Also we have solar distillation unit, also something, so that here we are going to in future how we can purify the arsenic water which is available in our food district. Then also we are going to have the aquaculture, you can say the pond, where we can integrate the GSPVT, also earth air heat exchanger. Also we are having the energy efficient building by using the insulation inside as well as the outside. So Risa, it is the end of my lecture, and if anyone wants to ask questions.
Okay, thank you, sir. It was such a wonderful lecture to hear about all the researches that you had done throughout this span of IIT and then BAGS Energy. Thank you so much, sir. Now, I would like to request the participants if they have any questions regarding the lecture, please come forward, type it in the chat box, or you can unmute yourself and you can ask sir directly.
Excuse me, sir.
Yes.
Sir, in many of your research paper, I read that in order to remove the heat from the back of the PV module, we can use the fluid either as a air or water. Can we use
Yes.
any other fluid?
No, other fuel can be expensive. Say, for space heating, you require air, which is freely available. And if you want to use hot water, so water is easily available. And suppose you are going to use some other fuel, there can be a problem of leakage. And to maintain the leakage is a serious problem. Because just see, even in our whole building or any water tank, other things, we don't have the very perfect system. So I will always suggest that an oil is generally used for power generation, very high temperature. So accordingly, you can go for CPCPVT. So there is a provision, but for our system, low temperature, I will never recommend that we should use any other fluid. Yes, nanoparticles, you can use that one. That is not a problem.
Sir, is there any research paper available on this nanoparticle? You are saying that?
Yes, we have published a lot of papers. You just go in Science Direct, put GMQRE, nanoparticle, you will find it. In solar distillation, maybe in the water tank, and there is a copper oxide. There are many component is given proportional, making the change in the concentration. You can find a different result. But if you ask me, by using the nanoparticle, there is only change in the heat transfer coefficient. But as far as the performance is concerned, I am not much encouraged out of that. For academic purpose, it is okay. But for practical purpose, I will not advise at low temperature, at least.
Okay, sir. Okay, sir. Thank you.
Any questions from other participants?
Okay,
Good
researcher,
afternoon,
thank you.
Professor.
Sure.
Hello.
Hello?
Good afternoon, Professor. Can
Yes.
you hear me?
Yes.
Yeah.
Actually, the solar PV materials are made up of silicon or else the carbon fiber. So, if there any material to replace this silica or a carbon fiber instead of for moving dynamics vehicles, because for silica as well as the carbon fibers are placed in a static systems like buildings or a wall, whatever. But when I place the system into automobile applications, like for dynamic purpose, so can you suggest any material?
First one thing, that is, I am not working on the solar cell material, but I can answer your question in a simple way. First, the crystalline based PV module is covering a market of 85 to 86%. And it is easily available in India as far as our country is concerned. That is the first thing. So, even if you are having the other material, for example, thin film technology is economical, but it is not available in our country. So, I can recommend thin film technology, but to get the thin film technology, thin film module, I will not say it is very difficult, but as far as maintenance is concerned, it may make it difficult. But it has more advantage than the opaque. Opaque classify two ways. One is the rigid PV module, one is the flexible rigid module. The flexible rigid module, generally in India we make aluminum based crystalline PV module. So it can be used for the e-rickshaw, we can use for the car, automobiles, and other things. And as far as building is concerned, other collector system, they are using this one. There, another thing, the material when used for the solar cell, stability is very, very important. The stability so far in other type of the solar cell material is not as good as the crystalline base. Second thing, in addition to stability, your life is important. That so far, as far as life is concerned, only competitive PV module are thin film and the crystalline base. Other module, because these has been used for the last many years back. Now whatever you are saying, there are many technologies which I have mentioned, generation 1, 2, 3, 4, but its availability is not at the industry level. Still,
Thank you,
research is
Professor.
going on. It is going on, but I don't know whether in our life we get it or not, because for the last 15 years, the stability is a lot of problem.
Okay. So I think we will conclude the session here. And I would like to thank Professor G.N. Tiwari, sir. It's a great honor to hear from you and the kind of researches you have been through all these years. Thank you so much, sir. And
My pleasure.
thank you, sir. Thank you.
Okay,
Okay, so I'll conclude this session, and the next session will be on WebEx itself. The previous links will be working for the